Alright, in this video I'm going to be reviewing solving equations, quadratic equations graphically, which I have here on the left, and I'm going to continue with a related exercise or problem that you can look at. I'm shown that here on the right. First, what I have on the left, I've got solve minus x squared plus 2x minus 1 is equal to x minus 3. Below it, the graph of both of those things. And yeah, we want to know when they're equal, what x can I find so that the this parabola gives the same value as this line. And so that's got to be these 2 points, because apparently when I can check when I put 2 into this linear formula, 2 minus 3 is minus 1. I get minus 1 there. Yeah, it's this minus 1, the distance from here to here. And when I put it into there, I get the 4, so minus 4 plus 2 times 2 plus 4 minus 4 plus 4 is 0. I get the minus 1. Obviously, so I get the same thing for the parabola. I get the same thing. Yeah, that's what the graph tells us. This point is the point where the x value is the same and the y value is the same. So yeah, one of the solutions must then be x is equal to 2. Yeah. The second one then is this point, is x is equal to minus 1. Because when you put x equals minus 1 into the form, you get minus 1 minus 3 is minus 4. When you put it in there, you also get the minus 4. Yeah, the y value, looking from the parabola's point of view, is minus 4, and also from the line's point of view is also minus 4. So that's kind of how we solve this graphically. Yeah, as an aside, let's say that we had this equation. Let's say we had minus x squared plus 2x minus 1 equal to 4. Yeah. What we're looking for here is that we're looking for which x the distance, or I should say minus 4, otherwise it doesn't work. Yeah, the distance from the x-axis is minus 4. Yeah, so we're really looking at this line. We're looking at the line, y equals minus 4. And why is this? This is the formula of that line. Why? Because, well, take any point on this line, and the y coordinate of any point on this line is equal to minus 4. The x coordinate can be anything, but the y coordinate is equal to minus 4. And then we can say that the solution to this equation, well, must be these 2 points, this one and that one. Yeah. So in other words, the solution to this is equal to x is equal to minus 1, or the x is equal to 3. Because when I put minus 1 into this parabola, I get minus 4. This minus 4. I want to put x equals 3 into the parabola. This one, you'll get what? 9 squared is minus 9, plus the 2 times 3 is 6, minus 9 plus 6 is minus 3, minus the 1 is the minus 4, so that checks out as well. So that was a review of really how we started this chapter on solving quadratic equations, which we first learned to do graphically. Okay, so now we're going to look at a similar problem to this one. And let me just read it. It says, find the intersection points of the parabola y equals minus x squared plus 2x minus 1. I've used the same parabola and the line y equals minus 3. So what I want to look at is the similarities and differences of this question as opposed to that question. And well, find the intersection points firstly. So what are we talking about then? We're talking about, obviously, we're talking about finding these 2 points. And we can see that there's no scale in this diagram, whereas there is here. So obviously, we already know the answer to the question. Yeah, we know the answer to the question are the 2 intersection points are 2 comma minus 1, and of course the minus 1 comma minus 4. These are the two answers to this question, but of course isolated like this, yeah, without getting this. We need to find these in a different way. We can't read it off the graph. We need to find it in a different way. The way we do that is to solve the equation algebraically. So the steps really are here is to solve the equation minus x squared plus 2x minus 1 equal to the x minus 3. We're going to solve this algebraically, obviously coming up with the solutions 2 and minus 1 because we already know that, but we're going to just go through those steps just to kind of illustrate it. And as a second step for each of those two x values, I'm going to put it back into one of the two to find the corresponding y value, and then I will get my 2 points. Again, these 2 points we're gonna show that we get those. So let me just solve this. This is a quadratic equation. We have to now solve it algebraically. I can't see the type, so what do? I must bring the x's to the left. So I'm just going to subtract an x from both sides. I'm just going to do this in one step and also add the 3 to both sides so that I get everything on the left and a 0 on the right. So that's going to give me minus minus an x squared. I've got 2x minus an x is plus an x. I have the minus 1 plus the 3 is plus a 2, and that will be equal to 0. I now need the number in front of the x squared to be a 1. It's at this point, it's a minus 1, so I'll multiply the entire equation by minus 1 both sides. Well, obviously 0 by minus 1 is still equal to 0, and this side becomes x squared minus x minus 2 is equal to 0. I can factor that into, let's see, an x minus 2 times an x plus 1 equal to 0, and that will give me that x is going to be equal to 2, or x is going to be equal to minus 1, which again, of course, we already knew. Yeah, we knew that x equals 2 is the solution and x equals minus 1 is the solution. But again, we might get this on a test where we don't have the scale and we're not able to read it off. Then we must solve that algebraically. Are we done? The answer is no, because it hasn't asked what is the x coordinate of those two intersection points. No, it's asking what are the intersections. So find the intersection points. In other words, we need an x and a y value for an answer. So what we do then is I take this x equals 2 and I put it into the formula, for example, of the line or the parabola. It doesn't matter. I could take the x equals 2 and put it either into the line or the parabola, because, well, I'm gonna get the same answer, of course, because that's the x we set out to find will give me the same y, so it doesn't matter. So if it doesn't matter, I'm going to choose the one obviously that's easiest, and that's going to be this line. Yeah, when I put 2 into this line, I get 2, yeah, minus the 3 is minus 1, so the point here is going to be so it's y is equal, just to kind of complete the steps, y is equal to 2 minus 3 is equal to minus 1. So therefore I get as an answer 2 and a minus 1. That's my first answer. I'll also put the into the line x minus y equals x minus 3. So it's this minus 1. Yeah, minus 1 minus 3. So then I'll get equal to minus 4, and the second point is then minus 1 minus 4. Again, yeah, both of these points we already knew. They're right here. Yeah, we already knew that. That was the answer. So that's how you do that. So what are the differences now? The difference is it doesn't say solve. And if it says solve, all you need to find are the x values. It says find the points. In other words, your answer is not a number. Your answer is these two things. This is the first answer, a point, and the second answer, also a point. Yeah. So that's the first difference. It says find the points. Second difference is that you're not solving the equation that you need to solve graphically. You're solving it algebraically. You're taking the steps here, finding the x, then putting the x back into one of the two formulas to find the corresponding y value. And that's how you do this class of problem.